Our next speaker will be Stephen Austin from TxDOT. Stephen is a Field Operations Section Director in the TxDOT Bridge Division, and he will present on TxDOT's recent experience with 2 overlays.
Good afternoon, and thank you all for attending this webinar. I'll start off by just saying that that it was through the TSP2 Southeast Bridge Preservation Partnership that we learned that TxDOT about a new overlay type that I'll be discussing today. It was an annual meeting and a presentation on the product that turned us on to polyester polymer concrete overlays. And so this presentation will highlight comparisons between polyester polymer concrete overlay and a concrete overlay installed on the same project. Related to implementing new materials and methods, I wanted to just share that at TxDOT we try to push for innovations and push for new materials, but try to find the locations with the lowest potential traffic impacts and maybe the lowest potential risks to test the product. The first overlay was a traditional concrete overlay, and the second was TxDOT's first polyester polymer concrete overlay. It's worth maybe me mentioning that we had many successful concrete overlay projects, and we're continuing to use both concrete and PPC depending on bridge deck conditions and the requirements for a project. So I mentioned there's this preservation project involved overlays over a series of 6 bridges in the Atlanta district, which is in the northeast part of Texas. These bridges were all built in 1965 or 1966, and the bridges are in relatively good condition with the exception of cracking, some spalling, exposed reinforcing in some cases attributed to decreased cover. So with our increased use of brine and de-icing salts in Texas, we were interested in performing some preservation actions to seal the cracking, to increase the durability of thin decks. Again, in 1965, 1966, we were trying to make the most optimized designs, and so we've got order of 6.5 inches to maybe 7 1/4 from that era that we wanted to make sure we sealed off and weren't allowing to continue to deteriorate. Also, the bridges had polished riding surfaces just from years of wear. The series of bridges are all overpasses crossing Interstate 20, and there's approximately 15 miles between the eastmost and the westmost bridges. The listing of the bridges is on the left, and then I've indicated there on the map on the right whether we apply a polyester polymer overlay or a concrete overlay. Blue indicates polyester, and that green dot indicates that for that bridge we used a concrete overlay. First bridges on the far west end of the project were twin structures constructed in 1960. This seemed like a perfect case study, perfect opportunity for a case study on comparing two products. Both of the bridges have 4-span pre-stressed beam superstructures. They have span lengths of 60 to 70 feet. All of the bridges that I'll be mentioning here are pre-stressed beams with span lengths between 40 and 75 feet, and they're all generally of this length, 265 feet or so. These two twin bridges here, have a 28-foot roadway. They have a 7 1/4-inch deck and 8-foot beam spacing. The bridges have transverse cracks, fine map cracks. They have a deck condition rating of 6. There was some joint spalls, and again the surface was polished, so it seemed like a good opportunity to try to get ahead of deterioration and seal these off. And the superstructure and the substructure on these bridges were pretty good condition. So we applied the 3/4-inch polyester polymer concrete overlay to the southbound bridge, and then on the northbound bridge we had a 2-inch concrete overlay applied. Interestingly, condition rating for the PPC bridge was raised to a 7, as the northbound bridge remained at 6. And you know that the condition is subject, even NHI will teach us that a 6, a 5, it could be a 7. You know, there's a tremendous amount, but it's worth just noting that the condition rating from one rating to the next, but it's not necessarily always the case. And again, there's just subjectivity with inspectors. So the next 3 overpasses heading east are similar bridges. This next one, County Road 31, 13-degree skew, spans 50 and 65. Overall length is 230 feet. This bridge deck is 6.5 inches thick, and the beams are spaced at 6 foot 8 inches. The next one, FM 968, has a more severe skew. It's got a 35-degree skew. Again, this one has a 24-foot roadway. The bridge deck is 6.5 inches thick, and the beam spacing is 6 foot 8. Moving on to the next and last bridge that we applied a PPC overlay on, the FM 3251 bridge, span lengths of 45 to about 70 foot with an overall length of 230 feet. The bridge deck on this one was 7.25 inch thick, and the beam spacing was 8 feet. This is the typical photos of the bridge decks for these 3 bridges that I just mentioned. Again, we applied the 3/4 inch PPC to seal the bridge decks and improve the surface friction. There were some transverse cracks you'll see, and some fine map cracking. A couple of areas where there had been a previous patch. Generally in good condition to apply an overlay. That there were some concrete repairs that were performed. Now, finally, the bridge at the far east end of the project is State Highway 43. This is another 4-span bridge. Span lengths were 55 to 72 foot in length, and the overall length of the bridge is 259 feet. The bridge is on a 30-degree skew and has a 56-foot roadway. So this is wider than the previous bridges that we just looked at. And this one has a 6.5 inch deck with 7.5 foot beam spacing. This one had a couple of locations of exposed reinforcing, transverse cracks. We applied the 2-inch concrete overlay to this one, in part because we had experience with concrete overlay. We didn't want to use this state highway as an experiment, maybe for our test application for PPC. So we thought that the 2-inch concrete overlay was maybe more appropriate at this bridge. So how did we get there with the PPC? Well, we created a special specification. Obviously, we're not the first state to do this. There have been several other states that have done this. So we pulled examples from other states for reference, and we worked with industry folks that are participants of TSP2 partnership, and we were able to write a spec to help make sure that we got the type of product, the product that we were looking for. This slide shows bid prices for the 2 deck preservation strategies. The top table is the concrete overlay with hydro demolition surface prep. And you'll see for this project, the total circled in blue is $59 per square yard. And we've got the kind of the contributing hydro demolition and the concrete overlay unit prices that were bid for this project. And then below that, we've got another table that summarizes the PPC overlay with the shot blast surface preparation. And again, for PPC application, the shot blast surface preparation is the recommendation. And to make sure that we applied a sound surface preparation, we went with hydro demolition for the concrete overlay. So you'll see that the PPC for this project came out significantly more expensive. And it was a little odd that I thought it was worth highlighting the statewide average bid prices, because the winning bid for this project just had a couple of outliers that stood out. For instance, the shot blasting that was bid on this project came in at $15 a square yard, whereas the statewide average bid prices is closer to $5 a square yard. I thought it was worth just sharing with you the bid prices if we were to combine hydro demolition and concrete overlay statewide versus PPC statewide. When we're selecting a concrete overlay, there need to be a few considerations. One of them is obviously the big benefit of using a concrete overlay on a bridge deck is to strengthen the bridge deck. That's probably one of the biggest benefits of using, like Pat mentioned, a cementitious or concrete overlay. Also, the thickness of the overlay will add load to the bridge and could affect the load rating. The load rating needs to be checked if we're going to add 2 inches of concrete thickness to an existing bridge. Also, increased thickness of a concrete overlay of 2 inches may require a rail retrofit if the rail height is no longer meets requirements. And then there's consideration of having to bring that 2-inch elevation change back down to grade. So I've shown a detail here on how we did that on this project, where we made up that difference on the approach slab, the 20-foot approach slab. Also, there are a few surface preparation options, and I mentioned hydro demolition being probably the better option, offering the strongest bond. I won't cover the items that Pat mentioned before, but certainly something that needs to be considered. Finally, the equipment setup time to prepare and perform work, curing time, and everything else all adds up. So duration of work is something that needs to be considered. We're finding that as we're implementing more and more preservation activities, a big part of the costs are going to traffic control, to shift traffic from one side to the other, or to redirect traffic. Whatever we can do to minimize the duration of work will help in the long run to allow our limited funding to go further. On our project, we called for a 2-inch overlay using a CO mix, which has a 0.4 max water to cement ratio. We had 7-day breaks of 7 KSI initially, and we ended up revising the mix design to bring that cement content down to avoid shrinkage cracking. We also called for steel fibers with a length of 1.5 inch and a dosage of 50 pounds per cubic yard. Maybe a little on the higher than average side, but we wanted to compare what we thought would be a durable concrete overlay to a PPC product. With a broom finish on the overlay because the bridges carry low speed traffic. And I said broom finish, but with a burlap mat, it kind of mats up the finish. The work on the concrete overlay was performed in the spring of 2019. The work consisted of milling bridge decks just lightly prior to hydro demolition. The milling went quick, but the hydro demolition on this project took as much as 4 to 5 days per phase. On the State Highway 43 bridge, for example, there were issues with water trucks that contributed to these delays. Also, forming took a number of days. Pouring took another day. And then we had a 4-day wet cure. Had we used LMC, that probably would have been 48 hours. Concrete overlay and our specs require a 4-day wet cure for that. Contractor issues were really, I think, contributed significantly to the longer than expected duration for this overlay. The concrete overlay had some plastic shrinkage cracks that they should have been sealed per TxDOT specs. Our office went out to evaluate the performance of the overlay nearly a year after it had been in service. The contractor argued that the bridges were too flexible, and that was maybe a contributing factor to the cracking. After being in service for a year, they still had not yet been sealed. In general, the overlay looked fine with the exception of the shrinkage cracks, and the joints on the concrete overlay we're holding up. On the left is a picture of an abutment back wall shown where, rather than risking a thin strip of concrete, the contractor chose to use a polymer material to avoid shelling out a thin section at the abutment, where the abutment back wall ended up becoming riding surface, essentially. Now we'll move on to shift gears to PPC design considerations. These are a few design considerations to determine if PPC is a good option on a bridge. Thin overlay option is less likely to require significant change in load rating or rail retrofit. The PPC system can offer skid resistance and seems to be a good addition to improving the barrier between de-icing chemicals and other chlorides to reinforcing steel. The PPC work was performed in March and April of 2019. The contractor planned to work one location at a time, but they were able to set up the traffic control signs for all of the locations and go through and cover and uncover signs as the work progressed. The overlay operations were performed by a specialty crew familiar with the product and installation. The specialty crew knew how to activate, knew how to work and reactivate the material. The crew was very efficient in that they were able to perform all the work per phase in one day. So what I'm showing there on the right in that image would have been completed in one day. Here are a few photos of the equipment and installation. Here are photos of the crew installing the PPC screed there. And then finally, broadcasting the aggregate to provide that skid resistance. Nearly a year after the installation, PPC was performing well with the exception of spalling and delaminations at the joints. That was what we thought was a disappointment because we had expected that there would be some forming going on. I'll kind of talk about these issues related to the joints. The joints were not beveled. The material, the PPC overlay was placed across the joint. Our understanding is that there's a critical timing for relief cuts at the joints that need to be performed within 2 hours for the product, in this case for the product on this project. Again, we would recommend using foam board or other method to isolate the joints and make sure that we're not missing the joint as they're come back in saw cut to form these joints. The PPC installer just returned to the project to repair the spalls. I think that happened just earlier this month. In fact, I'm happy to report that the joint issues and kind of the isolated locations there at the joint that were delaminated and spalling have been repaired. And hopefully they'll be holding up for a good long time once the joints are prepared properly. Here are a few observations. First, TxDOT has had a success with both overlay types, and sometimes it might depend on installation. It might depend on crews. There might be a number of factors that contribute to the success of an overlay system. And it seems that there's a whole lot of variability in concrete installation and techniques. In contrast, there's less risk in the polymer overlay due to, in this case, a specialty installation crew. When deck strength is not a concern, PPC may offer an economical solution is really our takeaway there. PPC can be installed quickly. It's installed much faster than traditional concrete overlay. And finally, joints are the riskiest part of an overlay installation. We need to be paying close attention to the joint work. But that's true of any system, not necessarily unique to PPC or anything else. So we need to make sure that joints get the attention that they need. On this project, the inspector and contractor seem to have had fewer challenges with the PPC. Finally, we believe that choosing these bridges for our first test of PPC proved to be a successful trial of the product, the polymer concrete overlay. And since then, we've had a number of projects let since our first trial. Here's a map that just kind of shows locations across Texas that have gone out. We continue to use concrete overlays in the right application and have added PPC to our toolbox. That kind of concludes my presentation for our product, or for our PPC and concrete overlay project. But I thought it might be worth me taking a few moments to share with you on behalf of TSP2, the Bridge Deck Preservation National Working Group, a resource that's available to help select a deck preservation product. The working group developed a bridge product database that can be accessed through the TSP2 website, and I've got a link here to the TSP2 website. Then there at the bottom, there's a link to a bridge product database. This link will take you to a web-based database with product information for overlays, sealers, and deck patching products. About a couple of years, we had overlays and sealers, and we just recently added the database for deck patching products. The information in this database can be viewed online or exported to Excel. The information available is supplied by vendors, and additionally, users are able to view comments from people that have experiences with various products. This database lists a number of different attributes for each product, the minimum thickness, the maximum thickness that would be recommended by the manufacturer, minimum or the estimated life in that the product can provide. So I thought I'd take just a couple of minutes to introduce that product if you have that database if you haven't already seen it. With that, I think I'll turn it back over to Bill. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.